Hello everyone. In this video, we are learning about Kirchhoff's law. Kirchhoff's law can be used to solve questions related to very simple circuit to very complex circuits, such as while designing the motherboards of a computer. There are two rules given by Kirchhoff. One is called as junction rule, and the another one is loop rule. They both complement each other. So what is this junction rule? Junction rule is also called as law of conservation of charge. Law of conservation of charge. And here is this rule. So imagine this is a point A and this point is acting as a junction. So the current entering at this point is, let's say, I1, and from any other direction the current is leaving, and that current is, imagine, I2. From some other direction, imagine there is current entering and this is I3, and in any other direction imagine the current is leaving, so this is I4, and you can take as many current as you want entering to the junction and leaving the junction. It doesn't matter as long as you are going to follow this junction rule. So what is this junction rule? So according to the junction rule, the sum of current entering at a point, and this point is junction. So sum of current entering at a junction should be is equal to sum of current leaving from that junction. Because whatever charge will enter, law of conservation of charge, whatever charge will enter at this junction, that will not disappear. It has to flow somewhere in other direction, either here or in some other direction. So whatever charge is entering at point A, same amount of charge should leave from point A, or you can say from the junction. So I can write the junction rule: I1 entering, I3 also entering. So I1 plus I3 should be is equal to I2 plus I4. So you can write something like this: summation I in is equal to summation of I out. This is junction rule. Now the loop rule is this law of conservation of energy. It means whatever energy you will give to the circuit, same amount of energy will dissipate in the circuit. It means energy given will be is equal to energy lost. So imagine I'm drawing a circuit somewhere here, something like this. This is a resistor, and these are two parallel resistors. Resistance of this resistor is R1, and for this resistor R2, and here R3, and the EMF of this cell is epsilon. So this is our complete circuit. Now imagine the current which is flowing in this circuit is I here. When current reaches at this point, you can apply the junction rule. I current is entering here, it will get divided into two parts. If I current or I1 current reaches here, I minus I1 will reach and flow through this R3. Why I minus I1? Because I was the total current reached at this point, which is the junction, and I1 got split at the upper part of this resistor, this circuit, and it's flowing through R2. Now the remaining current will find a path through R3. So the remaining current is I minus I1. Now to apply the loop rule, we can actually draw a loop within this circuit, and we are free to take any closed path as our loop. For example, I can take this one as our first loop. So imagine this is our first loop. So within this loop, there are two resistors and one power supply. So what are those resistors? One is this R1 and the another one is R3. Then this loop comes here, goes through this power supply of EMF epsilon, and this loop completes. We can take another loop, and that loop could be this loop of closed path. And let's say this is our loop 2. So the Kirchhoff's loop rule is law of conservation of energy, and if we apply the law of conservation of energy, then we can say that whatever energy will be given by this power supply, same energy will be consumed within this circuit. And if we consider any particular loop, so EMF in the loop, EMF of the power supply in the loop is equal to the total potential difference appearing within that loop across the resistors. So I can write here for loop 1, let's write the Kirchhoff's loop rule. So the EMF of the power supply within the loop, there may or may not be power supply, so don't worry about that. So if there is no power supply, you are supposed to write EMF as 0. So whatever is the EMF of the power supply within the loop, you will write, and here in our case it's epsilon. And now the EMF is epsilon for the power supply, and what is the potential difference across each resistor? For this resistor R1, EMF potential difference is IR1, and for R3 the EMF is I minus I1 R3. Why I am taking I minus I1? Because through this resistor R3, the current which is flowing is I minus I1. So you got the equation for the loop 1. Now what about loop 2? Loop 2. So for loop 2. In case of loop 2, there is no power supply within this loop. But what we have to consider is, we have to consider the direction of current in the direction of loop and opposite to the direction of loop. So what I do, though you are free to choose which direction you want to take as a positive or which direction you want to take as a negative, but what I do is, when the current is flowing in the direction of loop, I take it as a positive, and when the current is flowing against the direction of loop, I take it as negative. So same thing you can also do when the current is flowing in the direction of loop. We will take it as positive. So here I1 is positive, so I can write I1 R2. This is positive. Now if we go ahead and trace this loop, then we will find that this current I minus I1 is against the direction of the loop. So we will take this one as negative. So I1 R2 minus I minus I1 into R3, the resistance of the resistor, is equal to the potential difference within this loop. What is the potential difference within this loop? It's 0. So we will write 0. So this is the application of Kirchhoff's loop rule and the junction rule. An important point to remember here is junction rule is law of conservation of charge and loop rule is law of conservation of energy. Now, as a homework, you can apply this loop rule for the third loop, and the third loop we can form using this part. This is the third loop. It means R1, R2 and the power supply are the part of this loop. If you like the video, then hit the like and subscribe button and share with your friends so that they can also learn.